All right, hello and welcome to the new unit on exponential and logarithmic functions. Okay, some of this is going to be a review from Algebra 1. Some of this will be new since Algebra 1. Okay, so review will be the exponential part, and then the new stuff will be the logarithm stuff. Okay, again, very important topics in preparation for those of you who plan on going to pre-calculus and calculus. All right, so what is an exponential function? Okay, we've worked with functions that have exponents, right, in the past, but an exponential function is a different thing entirely. For an exponential function, the variable is in the exponent. Okay, our x variable is in the exponent. In the past, right, we've had like x to like the third, or like, x to the fifth, or x to the 1/2. Okay, those are all, those are not exponential functions. They all have exponents, but the variables are in the bases, right? Here in this case, our variable x is in the exponent, okay? And we have this unknown base, b, okay? It can kind of be interchangeable. You can have a 2, a 3, a 10, a 1/2, whatever kind of thing in there. But there are some stipulations. The b has to be greater than 0. That's because if you have a negative b value, then your x values are going to be kind of limited, right? Imagine putting like a 1/2 in for x here, and if your b was negative, okay, you'd be raising a negative number to the 1/2 exponent. It'd be imaginary, and you just have like a very funky kind of graph because you'd have like missing pieces and stuff like that. So we don't deal with b values that are negative. Also, we don't deal with b value being 1 because, of course, if b was just 1, well, you do 1 to the x and it would just be 1 the whole time. It wouldn't really be exponential. Okay, so as a note here, kind of what I hinted at earlier, there is no single parent function for exponential functions. Okay, we're going to have, it's going to change depending on the b value that we pick, okay, or that we're given. So let's take a look at this. Let's take a look at a b value of 2. Okay, so we're going to sketch a graph of f of x equals 2 to the x. Now, to do this, right, we'll do some of the mental math that's easy here. So let's try 0. 0 is going to be kind of like our reference point for these very basic untransformed functions that we are starting with, and then we'll talk about how we're going to transform things. So if I plug in 0, 2 to the 0 is 1, right? If I plug in 1, 2 to the 1 is not 1, it's 2. And if I plug in 2, 2 to the 2 is 4. Now if I plug in 2 to the negative 1, okay, so 2 to the negative 1, remember that's the same thing as 1 over 2 to the positive 1, or just 1/2. Okay, so this is 1/2. And then likewise, you can also do 2 to the negative 2, which is 1 over 2 to the positive 2, which is 1/4. And so we get 1/4 here. Okay, if I plot these points, see what we get. Okay, we get, so 0, 1 is this right here. Let's see what this graph looks like. 1, 2, 2, 4. And then negative 1, 1/2, so I'll estimate that to be right there, and then negative 2, 1/4, and I'll estimate that to be right there. And so if you kind of look here, we're going to end up with, and if I do 3, I can go ahead and just do 3. I know 3 is going to be 8, so I'll just go ahead and plot that point right there. And you kind of connect these dots here, you get this kind of curve, okay? And so this is an exponential growth curve. We'll talk, or graph, we'll talk about exponential decay the next lesson, I think. So what makes it growth? Well, it's increasing the whole time. All right, what's our domain here? Well, it looks like we can keep going to the left and we can keep going to the right. Okay, so that means we will be going from negative infinity to infinity, right? And we can kind of like convince ourselves that's true. If you were to look at the function that we started with, right, there's no way that we're going to divide by 0. There's no way we're going to take a square root of a negative number, so we're good to go. What's the y-intercept? Well, that's easy. It's 0, 1. Okay, where we intersect there. And that's going to be kind of like our main reference point we're going to kind of like use to help us when it comes to graphing these things, is transforming this y-intercept using our transformations and stuff, our translations and things. Horizontal asymptote. Now, if you look here, right, as we go to the right, we're going to infinity, right? So there's no horizontal asymptote here. However, as we go to the left, what y value are we approaching? Well, if you look here, right, we go from here, then to here, then to here, then to here. Okay, we're going to stay positive, but we're going to approach 0. So we have a horizontal asymptote at y equals 0. And of course, that asymptote will shift up or down if we're, transforming up or down kind of thing, shifting up or down. We do have y equals 0. If you don't believe me, you can actually go to the graphing calculator and type in, further and further negative values here. And you'll see that you'll always stay positive, but those numbers are going to get teeny, teeny, tiny, very, very close to 0. So then what's our range? Well, since we have a horizontal asymptote at 0, and we're never actually going to get to that 0, we're going to start our range at 0. That's our lowest y value, but we're not going to include it because we never get there. And then the highest y value will be infinity, and so we go up to infinity. Okay, so just to show you here real quick. So if I wanted to show my graphing calculator, okay, I'll just do that 2 to the x. Okay, and go to my table. Okay, and I'll type in some like negative numbers. So -3, -4, -5, -8, sure, why not? Just jump around there. -10. You get the idea. You can see those numbers are getting smaller and smaller and smaller, but still positive, still close to 0. -100. You can see it very, very small. That's 8 times 10 to the -31st. So it's like 0.000008, you know, kind of thing. So very, very close to 0. So you can kind of convince yourself there that we are going to, you know, 0 there for that horizontal asymptote. Okay, so there's our graph. Okay, of course we have our transformations here. All right, you know, you can, same stuff we've seen before. So we have a stretch or a shrink with that a value there. If the absolute value of a is greater than 1, it's a stretch, right? So if absolute value is between 0 and 1, it's a shrink. Of course, we can reflect over the x-axis if a is less than 0. So that would look like a graph like, instead of our growth like that, it would look like this. Okay, we don't really call that a decay. I mean, it's a decay, but it's not exponential decay. Well, I guess it's exponential. Anyway, this is the reflected graph there. That's what that would look like. We'll talk about exponential decay in the next lesson. Okay, we can shift left. Those are for h values less than 0. So if you have like x plus 3, you know, and the exponent there, that's to shift left 3. We can shift right, of course, you know. So if we have like an x minus 2 in the exponent there, that's a shift right 2. Okay, we can shift up or down, k units, of course, that plus k there. And so again, the plus 2 means we're going to go up 2, and the minus 4 means we're going to go down 4. Okay, so no surprises there. So let's take a look at actually graphing with transformations and stuff. All right, so we're going to state the domain and range of the function, identify new values of reference points, and the horizontal asymptote. Okay, the new values of the reference points, don't worry so much about that direction. We're just going to make a table. That's going to make it easier. Okay, so right away I can see here that we're going to be shifting left 2. So in my table that I'll make, instead of starting at 0 in the middle, we're going to shift everything left 2. Remember that in our old table we did this. Okay, so for our new table, we'll shift left 2, which means 0 going left 2, I'll start at -2. And then I'll just go to -3, and then -4. And then we'll do -1 and 0. Okay, I can see here that we're going to be shifting down 6, which means that horizontal asymptote that normally occurs here, okay, is going to occur down 6 from that. So it's going to occur at -6. I'm going to go ahead and just draw in my horizontal asymptote here, just to have that nice and ready to go. Okay. And then at this point, we can, you know, evaluate these by plugging them into x right up here, okay? Or you can use your graphing calculator. So I'm going to show you that here too. Okay, so 4 times 2 to the x plus 2 minus 6. So 4 times 2 to the... Now, if you have a new calculator like mine, and when you do the exponent, which is the button below clear there, it'll stay, everything will stay up in the exponent. You have to hit the arrow button to the right, then that gets you out of the exponent. Oops, not plus 6, minus 6. Okay, like that. Okay. If you have the older calculators, you'll need to use parentheses. When you press that caret button, you'll want to use parentheses for the start of the power, and then close the parentheses for the end of the power there. Okay, so just be careful with that. Make sure if you have an older calculator that doesn't like put it up in the exponent like this, that you put parentheses around your exponent, where it starts, where it ends, and then put the minus 6 at the end. Okay, so we go to our table here. Okay, so again we shifted left 2, so it would be -4, -3, -2, -1, and 0. Okay, and there we are. So it's -5, -4, -2, 2, 10. Goodness, I hope I got those right. -5, -4, -2, 2, 10. Okay, perfect. And we just plot these points. Okay, so -4, -5 will be right down here, halfway between the -4 and the -6. -3, -4, -2, -2, -1, 2, 0, 10. Okay, so again, you kind of get a feel for that growth there. and then just have the curve approach that asymptote, and then increase from there. And voila, there's our graph. So what's the domain? Domain. And the domain for all of these will always be negative infinity to infinity. There's no issue here with any of our x values. The range is going to be -6, right? -6 is the lowest y value we're going to approach. So, and again, approaching it, we put a parenthesis there, up to infinity. Okay? And then, the horizontal asymptote, HA y equals -6 from that shift there. Okay? So there we go. Do the same thing here for this one. Okay, so again, we're shifted left 1. So for our table, again, normally we would have -2, -1, 0, 1, and 2. But since we're shifting left 1, 0 will now be a -1. This will be -2. This will be -3. And then not negative. This will be 0, and then 1. Okay, just like that. Now, again, we'll go ahead and use our graphing calculator here. I'm not going to jump to the graphing calculator for this one. I'm just going to have it, I think I already have it. I'll just type it into my graphing calculator here with my hand because it's a lot faster. Okay, and let's see here. For -3, -2, -1, 0, and 1, I get 2.994, 2.94, 2.4, -3, and -57. Okay, so you can see because we have that base 10 here, that makes things, get really big really fast, or, grow really fast, or shrink really fast in this case. Okay, we're adding 3, so that means our horizontal asymptote, which is normally here at 0, is going to be shifted up 3. So right up here is our horizontal asymptote. And we'll just plot the points. So -3, 2.9994, like right up there. -2, 2.94, again, right up there. -1, -2.4, or 2.4, sorry. So it's going to be like right, a little bit lower. And then -1, or sorry, 0, -3, and then 1, -57, all the way down here. So you can see that we very quickly approach our horizontal asymptote, and then suddenly we drop off. Like that. Okay, and there's our graph. All right, next thing we're going to do is write the exponential function. Okay, I know I'm running a little bit late here, but again, this is pretty quick, I think. So we'll just get through this real quick. All right, write the exponential function that will produce the given graph. So here's our graph using the specified value for b. So they're going to have to give you the base, all right? So in this case, we're going to use 2, and then the next one we use 10. And they're going to state the domain and range. Okay, so let's use our information here. B is 2. So right now, our normal writing of the function would be y to the b, or b times, y equals a times b to the x minus h plus k. Now, some of this stuff we can already figure out. For example, we see our horizontal asymptote here is at 1. So that means k is going to be 1. Also, we're told that b is 2. So this b is going to be 2. Okay, like that. Now, the last thing here is which one of these points is the transformed point? Well, it turns out you can actually use either one. Okay, so for our purposes, just to make things a little bit easier, I'm going to recommend we just always use the leftmost point. So we're going to use this point for our shift. So what does that mean? So for our x-coordinate there, -1/3. So that means we are shifted to the left 1/3. So to shift to the left 1/3, this h value has got to become a +1/3. And so instead of that, I'll just put a +1/3 right there. Okay, in the exponent, of course. 2 to the x plus 1/3 power. So the last thing for us to do is to figure out what a is. That's where this other point's going to come in. We're going to plug it in. So we'll plug -5/3 in for y. We'll plug the 2/3 in for the x. Now, you might be like, fractions, Mr. Witt, oh no! But what's 2/3 plus 1/3? It's just 1, right? Okay, we'll subtract 1 from both sides then, and we'll start solving for a. So -5/3 minus 1, well, this is the same as -3/3. So if we subtract, we get -8/3 equals 2a. We'll divide both sides by 2. Okay, and so I'm going to run out of space, so I'll just do it over here. So what is a? Well, -8/3 divided by 2 is -4/3. And so our equation is y equals -4/3 times 2 to the x plus 1/3 plus 1. So what's the domain? Domain, negative infinity to infinity, which is always going to be the case, right? Because that's these exponential functions. There's no place where we're going to get undefined or anything like that. And the range, well, you can kind of see it right up here, right? But this case, right, the y value, the highest y value is 1, right? We're going to go up to that asymptote, and the lowest y value, we're going to go down to negative infinity. So there's a domain range. All right, last little bit here. Thanks for sticking with me. Okay, I'm just doing another example. If you feel good, feel free to stop and just move on. All right, so here, again, y equals a times b to the x minus h plus k. Our b, we're told, is 10. The horizontal asymptote is at negative 5/2. That means our shift here is going to be down 5/2. Okay, and then we're going to use this point as our reference point because it's the leftmost point. Again, you could use this one, and you'll result in a slightly different but still equivalent function. But I'm just going to, again, always, just for consistency's sake, use the left point. So y equals, so that means we're shifting right 3, so minus 3. So we're going to have y equals a times 10 to the x minus 3 minus 5/2. And again, we'll plug in this other point here to solve for a. So 1/2 in for a, 1/2 in for y because it's the y coordinate. 10 to the 4 minus 3, again, very easy, nice points there. So 4 minus 3 is just 1. I'll go ahead and just simplify that to 1, or just 10. We'll add the 5/2 to both sides. 1/2 plus 5/2 is 6/2, or 3. So we get 10a. So divide both sides by 10. A is 3/10. So our equation is y equals 3/10 times, 10 to the x minus 3 minus 5/2. And there's our equation. Okay, so I'm going to give you guys a homework assignment. We'll probably have like one of each kind of thing there. All right, thanks guys. Have a good day.